Well, we're going to be talking about the oxidation of alcohols. And as I mentioned earlier, oxidation can be defined as gain of oxygen and or loss of hydrogen. And we may also see an increase in bond order going from single to double to triple. In this case, what we'll be seeing is a single to double transition for the oxidation of alcohols. Taking a look at alcohols and identifying them, the first thing we need to do is be able to identify them as being primary or secondary. With primary alcohols, we're talking about one C being connected to the C with the OH, or another way of saying that is the OH is on the end of the compound. Secondary alcohols, you'll find there's two C's connected to the C with the OH, and that will mean that the OH is in the middle of the compound. The first thing we need to know about alcohols and oxidation is that we can get as many oxidations of an alcohol as we have hydrogens connected to the C with the OH. So for example, with a primary alcohol, we're going to have two H's connected to the C with the OH. That means there are two oxidations possible. Each oxidation will take away one of these hydrogens. So the first oxidation will take away two hydrogens, this one, and create the double bond for an aldehyde. This hydrogen, which is this one here, is still present. Then a second oxidation can occur that will remove that hydrogen and turn this into a carboxylic acid. This is only possible with primary alcohols because there are two hydrogens present on the C that has the OH. If you look at the harsh oxidizing agents and the mild oxidizing agents, now a mild oxidizing agent will allow just for one oxidation to occur, while a harsh oxidizing agent will cause both of these oxidations to occur. Effectively, with the harsh oxidizing agent, what's happening is that it's forming this compound first, and then, because it's a harsh oxidizing agent, it's allowing for the formation of the carboxylic acid as well by oxidation of this middle product. Alright, looking at mild oxidizing agents, the mild oxidizing agent we use most is PCC, or Pyridinium Chlorochromate. And if you look closely at it, what you'll see is this pyridine ring and this chromium trioxide, and these are joined together. It's like the chromium is sort of joined onto this ring, and that has the effect of reducing the activity of the oxidizing agent, making it mild and causing it only to cause one oxidation process. Now if we don't have this pyridine ring here and we just have straight CrO3, that's going to be a harsh oxidizing agent. There's nothing to slow it down, so it will do both oxidations. Alright, so let's take a look at a summary of what's going on. If you start off with a primary alcohol, this here is primary. Then what's going to happen is if you use PCC, a mild oxidizing agent, you'll just lose one of these hydrogens and you'll end up getting an aldehyde as a product. If you look at the pattern, really all you're doing is taking this OH and turning it into a double bonded oxygen by losing these two hydrogens, the H on the O and one of the H's on the C's. If we use CrO3, we're going to end up losing both of these hydrogens, and we're going to turn it into a carboxylic acid. So the OH turns into a C double bond O with an OH on it. Now remember, PCC is mild, so it just gives the aldehyde. CrO3 is harsh, so it will give the aldehyde first, but then oxidize the aldehyde into the carboxylic acid, and we're never going to see the aldehyde. Right, with the secondary alcohols, it doesn't matter if we use a mild or a harsh oxidizing agent because there is only one hydrogen on the C with the OH, which means only one oxidation is possible. So both of those will form a ketone by losing the H on the O here and the H on the C. And you can see the pattern is the OH single bond turns into a C double bond O. With a tertiary, there are no hydrogens connected to the C with the OH, so no oxidations will be possible. Here's another couple of examples. Primary alcohol, same one in each case, we use PCC, we get the aldehyde. Again, look at the pattern, single bond turns into a double bonded oxygen. CrO3, the primary OH turns into a carboxylic acid. So the same number of carbons, the COH turns into a C double bond O with an OH on it. Secondary alcohols, as you can see, we use PCC or CrO3 on the same secondary alcohol. We're going to get exactly the same product, which will be a ketone. Again, one oxidation due to the fact there's only one hydrogen on the C with the OH.